The following content has been provided by RWTH Aachen University.
I recommend taking a look at Jeff's book, that chapter on responsiveness, and read up on it to see more examples and get more detail about this. The design techniques for responsiveness are mostly, well, they're really not that hard. It basically says meet the human deadlines. So make sure that you match those human time deadlines. The three deadlines, recognize the differences between them. When does which deadline apply? When does which deadline become important to you? And mostly just acknowledge any user input immediately and display busy or progress indicators as needed. Use them as frequently as you can because you never know when it will take longer. To give you an example, when I open a new window in the Finder on my Mac, it's supposed to show the contents of that directory, right? Sometimes, with local directories, it's never a problem. Sometimes it's a network directory that's over a fairly slow connection, let's say, and you open that window, and it takes several seconds for the contents to load. That's not unusual if I'm in the USA and I need to open my home folder on my network drive here on our file server in the department here in Germany. That's going to take a few seconds. The funny thing is that I almost never get proper progress bars in this case. Somehow the Finder just assumes everything happens instantly, and there are a lot of cases where the Finder seems to hang, essentially. You don't know what's going on. You don't even know whether content is still going to come, whether it's done showing you all the files in a directory, or whether that directory is empty. So that's an example where clearly design was with the local file system in mind, where loading a directory for a folder takes a few milliseconds at most. And now with network file systems, that never got updated, so all of a sudden you have a system that is not showing progress indicators, although the delays are clearly over 1 second. Talking about progress bars, I already told you about the progress bar. We had the Windows progress bar, the old one, right, that we made a little fun of. If you design progress bars, don't make them stop at 99% and then go on forever, right? Make them realistic. So, for example, don't show a progress bar for each part of the interaction that's going on, but show one for everything in total. Because I'm really just interested when the system is done as a user, right? Can I get myself a coffee or not? Try to estimate the total time remaining. Estimate. Don't try to be too specific, too concrete, because you're going to be wrong anyway. And make them advance linearly. I think that's something we already talked about. Make sure if you have an estimate that this estimate never goes up unless something completely unexpected happens, like somebody pulls the network plug or something. And less than a minute makes more sense than 47 seconds. We've talked about those when we talked about the Windows progress bar already. So progress bars are really, really helpful feedback to users. We see them a lot, and that's good that they do come up when there is a delay that the system cannot avoid. Of course, it'd be even nicer if you can avoid the delay somehow, but not always your choice. And then these are more interesting, because this other one is just progress bar. Although, like I said when we talked about the Windows progress bars aren't easy, because estimating how much time it's going to take to complete a task that you've just begun in your software is not a trivial task. You may need to collect statistics from past runs to estimate how it's going to go this time. You may need to look at the total amount of data that you need to process, how much you've already processed, estimate that. You may need to take into account that lots of small files take longer than one big file, all those kinds of things, if it's a copying dialog, for example. These are more tricky, maybe. One of the things is display important information first. Back in the Stone Age of computing, when the X Windows system came out, there was a little tool on there that was called X Clock, which showed you a little analog clock on the screen. And I'm going to talk about this more in DIS2 next semester, so come back. But the X Windows system had one particular thing that was unique about it. Does anybody happen to know, because you tried it out? Does that ring a bell, X Windows system? No? If you're using Linux, you're still running some kind of variant of it, yeah?
You had the option to forward windows over the network.
Exactly, you got the option, it's a good description, to forward windows over the network. Essentially, the whole graphics rendering could happen on a totally different machine than the application that was running. So it could send its output over the network to some distant screen. It's kind of like what you know today from like VNC tools, but in a more architecturally unified way. Now the point of that is that back in the days, network connections were really slow. And this clock application could be running on one computer, was trying to render its analog clock phase on a different computer. So when it started up, what do you think it was drawing first? It had to draw a couple lines and stuff to draw an analog clock phase. What was the very first thing it would draw? What was the very first thing you would draw if you had to do an analog clock application and you may have a very slow connection? What do you start with? Yeah.
The indicators?
The indicator. So the hands. Yeah. Okay. Which one goes first? We have a really slow connection now. So
minutes, or even now seconds not, because that's we have to update that, but minutes then probably.
What about the hours?
Well, the user probably knows roughly what time it is, so the hours probably knows more or less.
That's an interesting.
Minutes are more relevant.
That's an interesting argument. We could have a discussion on that. The X-Clock designers decided differently. They decided to draw the hour first, thinking that if I never ever get to draw the minutes, at least somebody who sees just this stubby little indicator roughly knows that it's somewhere between, I don't know, what, 4 and 5 maybe. So they drew the hour indicator first, and then the minute indicator. You're right, the seconds didn't come. And then it would say, whatever, minutes maybe down here, right? So now we knew. And if you only got to draw these two lines, then the user would already know pretty much what time it is, because you can estimate from that. What's next? Yeah.
The hours and then the seconds, because if the connection is really slow, then by the time I drew the second indicator and then the hour, the seconds will have changed.
So the hand for the seconds, yeah, that actually, I think that came at the very last moment.
I said hour first.
And yeah. So we have hours and minutes now. We have the hands for the hours and the minutes. Yes. So as far as I remember, the second indicator wasn't the next thing that was drawn. It was giving people an idea, if they had trouble estimating what this was, to know what time this is. So what would you need to draw for next then? Yeah?
I would draw some points at 12 o'clock, 3 o'clock, 6, or 9 o'clock.
That's exactly what these guys did. So the next thing was they would do these things so that you would know then, what's coming next. And then they would fill in, the ones in between. And then they would maybe number them again. First put like 12, 3, 6, 9. And then possibly do, these markers all the way around. And then draw the second hand and stuff like this. But this seems ridiculous because like, hey, how long can it possibly take to draw a clock? But if you are on a GSM modem connection in rural Tanzania and you're trying to see that clock happening that's being rendered on your server in Taipei, that might be an issue, right? So this can take really long. And it doesn't hurt to use that order. If the thing happens really quickly, nobody will tell the difference, right? It's not worse than the other solution of maybe drawing first the circle here. But if this connection is ever slow, you've basically safeguarded your system against those kinds of problems. Yeah?
I have a question regarding updating the interface. When the seconds handle passed over an indicator, did it actually overlap? Because in that case, I imagine that you would somehow have to erase that again, or at least use layers. What kind of system was used for this?
So for that, the early drawing tools, this was basically a black and white system, but early drawing tools would often use the XOR trick to do the redraws. We'll also talk about this in DIS2. Thanks for bringing it up. So it's a wonderful class to take. But the XOR trick, in a nutshell, means that if you XOR the contents of the screen with a new shape you want to show on top of that, it will appear as an inverted shape. You will always be able to see it, no matter what the background is. Plus, if you draw it again with the same XOR logic on the same place, it'll go away again, and you've got your background restored. So XOR is the only operation that can actually, you can apply it twice to the background with a foreground mask, and the mask will be erased again and the background restored. Somebody actually tried to patent that. I don't know how that ever went, but it's a common trick, and that would be what you do with the seconds hand, so you get your minutes hand back at that point. But I was mostly talking here about the first time rendering, right, when you build up the UI when the system launches.
This content was provided by RWTH Aachen University.